Okay, last part of this, we're going to talk about the binomial theorem. Now, we talked about this a little last year as well, but not really in the aspect of what we're going to talk about it this year. So, getting started, what is the binomial theorem? Well, our binomial theorem says that if I have a plus b to the n power, that's going to equal the summation from r equals 0 to whatever my n value is, okay, of n choosing r. Remember, this is our combination. Okay, we talked about this last year in Algebra 2. If I have n choosing r, okay, that means n factorial over r factorial times n minus r factorial. Okay, n choosing r also means, hey, there's a button on your calculator that you can use to figure that out. Okay, button on your calculator is under the PRB. You'll have to click on that button and then you'll be able to scroll over to find it. Okay, and then I've got an a to the n minus r power and a b to the r power. Whoa, that's a lot of stuff there. Okay, now, just make sure we understand. This a right here coordinates with whatever this a is right there. So that's where the a comes from. The b, you guessed it, comes from right over here. Okay, and then our n value, which there's an n here, there's an n here, there's an n here. All of those n values come from whatever this n value is here. Okay, so everything is based on this binomial thing that we have done before. Okay, everything is based on this binomial. All right, our r value, if you guys remember, summations start with whatever this number is. So the first time through, I'm going to plug in a 0 for all of these r's. Then I'm going to have a plus sign because it's a summation. Then the next time through, I'm going to have a 1 for all of those r's. Then I'm going to have a 2 for all of those r's. Then plus, I'm going to have a 3 with all those r's until we get to whatever our n value is. Okay? Now, this is the most complex summation that you guys have seen. Okay? But this is a way that we can expand binomials. The last slide, we went over how to expand binomials using our Pascal's triangle. Okay? This is another option to expand. You can either do Pascal's triangle or you can do the binomial theorem. And I think most of you guys will do Pascal's triangle because last year I showed you guys this formula, but then we kind of skipped over it because we were like, that's pretty complex. We haven't talked about summations. But since we have talked about summations, I'm going to show you real quick. Okay? So we have our binomial theorem. My a is an x, so I plug that in. My b is a y, so I plug that in. My 3 is my n value, so my 3 goes to the top of the summation. I plug in a 3 for my n value here and a 3 for my n value here. The rest of these values stay as r because they're going to change. My r value is going to start at 0, then it's going to go 1, then 2, then 3. So if you guys look, my first set here, all of my r values are 0. Okay? So there's my first term. Then I've got my plus sign. Then all of my r values are 1. I've got my plus sign. Then all of my r values are 2. I've got a plus sign. Then all of my r values are 3. And that's my final answer. Okay? If you plug into your calculator, hit the 3 first, then hit your PRB button to find your combination, then you'll enter in a 0. When you do that, you'll find out that this gives you 1. Then I've got an x to the 3 minus 0. Well, that's just an x cubed. Then I've got a y to the 0 power. That's 1. If I plug in 3 choosing 1, okay, again, hit the 3 first, then hit the PRB button, press enter, then hit the 1. Okay, that will give me a plus 3 times x to the 3 minus 1 gives me x squared. Y to the 1 is just a y. Then plus 3 choosing 2, again, that gives me a 3. I've got x to the first, y squared. 3 choosing 3 here at the end, plus sign 3 choosing 3 gives me 1. Gives me x to the 0 power, y cubed. Okay? X to the 0 power would just be a 1. Okay? And if you guys look, once we get to this point, we're right at where Pascal's triangle is. Okay? So if you really like the summations and you want to do summations to expand Pascal's triangle, go for it. Okay? You can use the binomial theorem. I think in all my years of teaching, I've only had one student that preferred the binomial theorem. But if you want to do the binomial theorem to expand, you can. Okay? Or you can just do the Pascal's triangle, which is what we've been doing in the past. Okay? So that is entirely up to you what you want to do. So most of you guys may be thinking, wow, I just wasted 5 minutes and 12 seconds learning about something I'm not going to use. Well, we will use your binomial theorem for something else. Okay? And what we're going to use our binomial theorem for is we're going to use it to find specific terms. Okay? When I took a number theory class in college, they would give a binomial x plus 2 to the 1,000th power. Okay? I am not going to work that out to the 1,000th power. And they didn't want me to. They wanted me to find the 999th term. Well, I had no clue how to do that. Okay? But if I had the binomial theorem, I would have known. Okay? So what we do is our binomial theorem, we have our summation with r equals 0 to the n power, right? That's my binomial theorem. Well, to use it to find a specific term, since I'm only looking for one term, I don't need the summation part. Okay? I need to know that a plus b to the n power is going to give me n choosing r, a to the n minus r, and b to the r. Okay? So I'm only looking for one term. So starting out in this example down below, I've got a 2x. Well, 2x is my a, right? So that's going to go in for my a here. I've got a positive 4. That's my b. So I'm going to have to plug in a 4 here. And then my n value is 7. That's my n. So I'm going to have to plug in an n here, or a 7 there, and a 7 there. Okay? So the only value I don't have is my r value. Well, my r value comes from this right here. Okay? That's going to tell me my r value. Okay. Now, real quick, something that we need to look at back on our last slide here, and I know there's going to be marks on it. Ignore the marks. Okay? Back here on this last slide. This is my first term. What's my r value on my first term? 0. This is my second term. What's my r value on my second term? 1. So our r value is always 1 less. Okay? So if I'm looking for the sixth term, I need to do 1 less. So if I'm looking for the sixth term, my r value, whoops, went the wrong way. My r value needs to be 5. Okay? So let's make a note up here. R value is always 1 less. R value is always 1 less. So if I'm looking for the sixth term, my r value is going to equal 5. So I'm going to plug that 5 in here, that 5 in here, and that 5 in here. Okay? So let's go ahead and do that then. I'm going to have an n, which my n was 7, so I've got a 7 choosing, and my r value we said was 5. Okay, that's the first thing. Then I'm going to take that times an a value, which my a value is 2x. I just wrote an n for some reason. My a value is 2x, and I'm going to take that 2x to the n, which my n is 7, okay, minus 5 power. And then my last one I've got my b value, which my b value is 4, and I'm going to take that 4 to the 5th power. Okay? So we need to know this just so that we know what to plug it into to find that specific term. Okay? Now, you're going to plug in your calculator. When I plug this in my calculator, do this with me. I'm going to plug in my 7 first. Then I'm going to hit the PRB button. I'm going to have to scroll over, up or down, left or right, one of those two, and you're going to see a button that says NCR. I need to press enter on that button. Then I'm going to enter in a 5. Okay, when you enter it in your calculator, it'll look like this. You had a 7, then you hit an NCR, then you entered in a 5. Once it looks like that, you're going to press enter. Okay, and 7 choosing 5. Oh, geez. I don't know that one. 7 choosing 5, 7th row, 1, 7. Oh, geez. I really don't know that one. I'm going to have to pause. All right, I'm back. Found a calculator. Okay, 7 choosing 5 is going to give me 21. Okay, then I've got a 2x to the 7 minus 5 power. 7 minus 5 would just be 2. So that's a 2x squared. Squared has to go to the 2 and to the x. So that gives me a 4x squared. And then I've got a 4 to the 5th power, which I believe is 1024. Check that real quick. 4 to the 5th power. Yep, 1024. So now I need to multiply all three of these together. So I'm going to take 21 times 4 times 1024. And that gives me 86,016. X squared. Don't forget your x squared at the end. Okay? So the only thing that you have to use your binomial theorem for is you have to use it to find a specific term. You can, however, use your binomial theorem to expand if you want to, or you can use Pascal's triangle. And on your test, you can do either one. Okay, so whichever one you guys feel comfortable with.